Hello everyone, I'm Shirley and today I'm going to showing you guys how to do number 1, 5, and 7 from one of the past papers. Code name 9709, summer 22, paper 41. Let's read it. A car starts from rest and moves in a straight line with constant acceleration for a distance of 200 meters, reaching a speed of 25 meters per second. The car then travels at the speed for 400 meters before decelerating uniformly to rest over a period of 5 seconds. Find the time for which the car is accelerating, so that we can all understand. Um, so, okay. So, okay, for the first part, it says that the car starts from rest and with constant acceleration for a distance of 200 meters. So I'll assume that this section will be that part. Okay, so it starts at rest, so u is 0, and then the distance is 200 meters, and the v here is it's at 25, so 25 is v, and then it says that the car then travels at the speed for 400 meters. So I'll assume that from here to here, the speed will be 25 meters per second and it doesn't change. So constant speed. I mean, I usually like draw before I answer every question. So yeah. So here is d equals to 400 meters. And then it starts decelerating uniformly to rest over a period of 5 seconds. So what we know here is the time. So t here is 5 seconds. This is after it has experienced constant speed. So it decelerates after it experienced constant speed. So here we know that the v is 0 because it's at 2 rest. So v here is 0. Okay, so the question asks me, find the time for which the car is accelerating. So since this part is decelerating, we can ignore this part. We can ignore this part. Ignore. I'll just write it in red so that you can understand and not be mixed up. So we just need to focus on this part. This part. So we need to use the Suvat formula. What is the formula which incorporates S, U, and V to find the time? That's right. We need to use the S equals to U plus V over 2 times T. So now we just need to plug in the numbers. U equals to 0, V equals to 25, and D equals to 200 meters. Because this part is the only section where the car experienced acceleration. So we have 200 meters here, and then we have the U is 0, V is 25, divided by 2 times T. So we have 200 equals to 25 over 2T. And I get, wait, I'm gonna use my calculator, 16 seconds. So that's the answer. Just gonna highlight it so you can see it clearly. Okay, so now we need to sketch the velocity time graph for the motion of the car, showing the key points. Okay, so as I have divided the diagram into 3 different parts, so I'll assume that's number 1, number 2, and number 3. So a velocity time graph. What is the x-axis and y-axis? Well, since it's set velocity time graph, then the x-axis should be the, yes, that's right, it should be the time. Oh no, I almost got it mixed up. Okay, so I'm drawing. It's gonna take some time because I want to make it neat so that you can see clearly. This one's okay. I'll label it first. Don't forget to label it, you guys, because the examiner would know what graph is this. So put here. Okay, so what I normally do is, what you should also do is finding the time for each second, each sections. So like what we know here is first section, right? The first section we already got it, 16 seconds. Okay, let's write it here. So t equals to 16, and what is the v here? It's 25. So no, I mean it start accelerating from 0 until 25. So I'll assume that the first part of the motion is accelerating and it starts from 0 from origin to 25. So I'll write it 25. So I don't forget, I'll write accelerating here. And for the second section, it moves at a constant speed. So when an object moves in a constant speed, the line of the graph will show a straight horizontal line. So, but then we don't know how many seconds does it spend when doing constant speed. Okay, so now it's our job to find out how many seconds it experienced constant speed. So what do? We use the formula, okay? So we have S equals to 400, and then the V is 25, but it moves at a constant speed. So we have to go back to our basics. We don't need the Suvat formula because it moves at a constant speed. We could easily use the T equals to S over V. So 400 divided by 25 is, calculator, 16 seconds. Wow, same, yeah. Alright, constant here so that I don't forget, guys. And lastly, for the third section. Okay, the third section, the question said that the car was decelerating. Okay, so we don't really need to count anything, but yeah, we just need to graph it out because we already know like how many seconds it spent in decelerating, and also we already know that it reaches 0. So what do we need to do now? Start drawing the graph. Okay, so start from 0, and okay, I'll draw the first part first, which is accelerating. You don't really need a very accurate graph, but okay, just showing the key points, right? So I'll just assume this is about 16, and yeah, okay. So I'm gonna draw somewhere here, 25 here. Okay, got it. Okay, so now what I'm gonna do is, since I'm quite I have like trust issues with my drawing, I'm gonna like draw like broken lines first, so that I can like create like a better graph. Because I'm not using my paper right now, like my physical paper. Okay, it's a good one. So now going down. Okay, it's quite good. Okay, kind of nervous. Okay, so now I'm gonna draw for the second section, which is moving at a constant speed. So just gonna assume until here is about, because it says 16 seconds is spent to move at constant speed, then it should be 32 seconds, right? Here. So I'm gonna, okay, never mind. I'm just gonna like draw a straight line. No, I don't need it. Oh. Yeah. Okay. And it says it decelerates to 0, of course, and it will decelerate for 5 seconds. So here will be 37, right? I'm gonna draw a slope, negative slope here. And yeah, there you go. So now we have the velocity time graph. Yep, okay. Now, moving on to the next question. Find the average speed of the car during its motion. Okay, this is easy, guys. Don't get intimidated. Okay, so what do we do? Firstly, we need to find... So, okay, I'll ask you. What does average speed means? It is basically total distance over time. So please remember, every time you encounter the word average speed, that means total distance over time. So I'm gonna write it so that you guys like it'll be like engraved in your brains. We need average speed. To find the average speed, what I need to do, what we have known is the distance for number 1 and number 2, right? Why is my screen like that? What we don't know is section 3, right? Like we don't know the distance, how long, I mean like how many meters it traveled when it decelerates. So, as usual, we need to draw it first. I mean, no, not draw it. sorry. We need to find it first. Okay, so what I'm going to do is I'm going to start with using formula. So what formula? It can work here, but we just need to use the normal acceleration formula, which is A equals to VF minus VI. V final minus V initial over time. Because we don't know the acceleration of section 3. We don't know what is the magnitude of this acceleration. We need to find it out first, then we can get the magnitude of the displacement. So, what is the V final? 0. What is the V initial? Uh, 25.2. So I'm gonna write 25 here, and the time is 5 seconds, as you know. So, negative 5 meters. Okay, so now we're now safe to find the distance it traveled. So I'm going to use the v squared equals to u squared plus 2as. So the v squared will be 0, of course, and then we have the u here, which will be 25. So, and acceleration is negative 5, and the displacement is the one we want to know. So I'm gonna move it to here, right? 10s equals to 625, s equals to 62.5 meters. So this is the distance that the car travels at section 3. Now, what I'm going to do is just plug in the numbers as usual. Total distance, which means from part 1 until part 3. So what we know is... Sorry, my screen just doesn't coordinate with me, okay? So firstly, 200 and 400. Okay, I'm just gonna like remember it so that I don't really go back and forth. 200 plus 400 plus 62.5. 62.5 divided by the total time, which is before 37, right? Okay. So now use your calculators, guys, because yeah, I suck at like basic math. Haha. Okay. The answer is 17.905 blah 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 blah. But I'm just gonna round it to two significant figures. No, I mean three, because I want more accurate. So I will round it as 18.0 meter per second.
Question 2.
Should be in three.
Two particles, P and Q, of masses 0.5 kilograms and 0.3 kilograms respectively, are connected by a light and extensible string. The string is taut and P is vertically above Q. A force of magnitude 10 newtons is applied to P vertically upwards. Find the acceleration of the particles and the tension in the string connecting them. Okay, so first let's draw the diagram. It's mentioned that P is vertically above Q, and they're connected by a string. So there will be tension acting in this direction. And then moving on, we have to write down their weights. The mass of Q is 0.3 kilograms, so its weight is 3 newtons. And for P, the mass is 0.5 kilograms, so its weight is 5 newtons. And lastly, a force of magnitude 10 newtons is applied to P vertically upwards. So this is the diagram. Moving on, we have to find the acceleration of the particles and the tension in the string. So let's find the acceleration first. We can use Newton's second law for that, which is F equals to ma. So we can find the forces for both P and Q individually first. So for P, we can pick the upwards direction as positive. So for P, it would be 10 newtons, this one, minus 5 minus T, which will be equal to, its mass is 0.5 kilograms, so it's 0.5 A. While for Q, the one acting upwards is the tension, so T minus 3. And its mass is 0.3 kilograms, so it's 0.3 A. Next, we just have to add both of these up so that we can cancel out the tension. So since the tension is cancelled out, the remaining is 2 on the left side and 0.8 A. And so we can find the acceleration by 2 divided by 0.8, which will equal to 2.5 meter per second squared. So this is the acceleration. And then after we find the acceleration, we also have to find the tension. We can use either one of the equations, but since the equation for Q is more simple, I'll just use that one. So T minus 3 equals to 0.3 A. And then we can substitute 2.5 meter per second squared. So T minus 3 equals to 0.3 multiplied by 2.5. So T would be equal to 0.75 plus 3. So T is 3.75 newtons. So the tension is 3.75 newtons and the acceleration is 2.5 meter per second squared. Moving on to question number 3. A crate of mass 300 kilograms is at rest on a rough horizontal ground. The coefficient of friction between the crate and the ground is 0.5. A force of magnitude x newtons, acting at an angle alpha above the horizontal, is applied to the crate, where sine alpha is 0.28. Find the greatest value of x for which the crate remains at rest. So first of all, let's draw the diagram. If this is the crate, and it's on a rough horizontal ground, so that means there will be friction acting on it. And aside from that, there will also be the weight. Since its mass is 300 kilograms, so the weight will be 3,000 newtons. And then there's also the normal force. And lastly, there's a force x, which is acting at an angle alpha. So force x can be broken down to its x and y components, so we can draw that. This is the x component of, this is the y component of x, and this is the x component of force x. So since sine alpha is 0.28, and so we can find cos alpha by, first we can find sine inverse of 0.28, and then we can cos that answer. So that is 0.96. So let's analyze the question again. It says the crate remains at rest. The greatest value of x for which the crate remains at rest. So that means that's when it's at equilibrium. So in the x direction, the force xx will be equal to the friction force. So let's first find force xx and xy. Xx would be x cos alpha, which is 0.96x. And xy is x sine alpha, so it is 0.28x. And then we can find the normal force too. If we look in the direction, the forces on the y direction also have to be in equilibrium. So the weight, 3,000 newtons, would be equal to n and xy, the normal force, and force x in the y direction. So n would be equal to 3,000 minus xy, which is 0.28x. And since we already know what the normal force is, then we can find the friction force, which is the normal force multiplied by the coefficient of friction. So it's 0.5, it's written here, multiplied by normal force, 3000 minus 0.28x. So it would be 1500 minus 0.14x. So now we have two equations for friction, this one, and the friction is equal to the x component of force x. So we can equate those two. The x component of x would be 0.96x is equal to 1500 minus 0.14x. So if we move the x to the right side, we can find that 1.10x is equal to 1500. So x is equal to 1360 newtons. Question 4. Three coplanar forces of magnitude 20 newtons, 100 newtons, and F newtons act at a point. The direction of these forces are shown in the diagram. Given that the three forces are in equilibrium, find F and alpha. So first, let's break down all these forces into their x and y components. For the 20 newton force, its x component is 20 sine 40, and its y component, oh my god, fuck. Okay. Question 4. Three coplanar forces of magnitude 20 newtons, 100 newtons, and F newtons act at a point. The direction of these forces are shown in the diagram. Given that the three forces are in equilibrium, find F and alpha. So first, let's break down all these forces into their x and y components. For the 20 newton force, its y component is 20 sine 40, and its x component is 20 cos 40. For the 100 newton force, its y component is 100 cos 20, and its x component is 100 sine 20. And for the force F, its x component is F cos alpha, and its y component is F sine alpha. And then in the question it says that the forces are in equilibrium. So we can say that the forces in the x direction is equal to 0, and the net force in the y direction is also equal to 0. So first, let's look at the forces in the x direction. So F cos alpha minus 20 cos 40 minus 100 sine 20 is equal to 0. The 20 cos 40 and 100 sine 20 is negative because they're in the opposite direction. So from this, we can find that F cos alpha is 49.5. Next, we're going to look at the forces in the y direction. So 20 sine 40 plus F sine alpha minus 100 cos 20 is equal to 0. The 100 cos 20 is also negative because it's in the opposite direction. It's acting downwards. That's why it's negative. So we can find that F sine alpha is equals to 81.1. Next, we're going to divide this equation with this equation. So F sine alpha divided by F cos alpha, which would be tan alpha, is equal to 81.1 over 49.5. So from this, we can find the value of alpha, which is 58.6 degrees. After we find the value of alpha, we can substitute it to either this equation or this equation. I'm going to pick this F sine alpha equals to 81.1. So we can just substitute it. So F sine 58.6 is equal to 81.1. So we can find that the force F is equal to 95.0 newtons.
So I'm gonna read it, yeah. Two racing cars, A and B, are at rest. So they are at rest at first, alongside each other at a point O on a straight horizontal test track. The mass of A is 1,200 kilograms. The engine of A produces a constant driving force of 4,500 newtons. Why does it not? Hello? My screen is so bad. Yeah, finally. So when A arrives at a point P, its speed is 25 meters per second. The distance OP is d meters, and the work done against the resistance force experienced by A between O and P is 75,000 joules. So that D equals to 100. So this is a proving question. Okay, this will be easy because you already know the answer. You just need to find out how to get to the answer, right? Okay, so as usual, I want to draw my diagram now because like I don't want to be confused. Okay, so what we know here, we have two objects, A and B. But yeah, okay, A and B. Okay. But since the question didn't really discuss about object B here, I'm just gonna assume it's not within the motion, right? Okay. Okay, so firstly, I'm gonna have A here, but I'm still gonna draw B, just in case, you know? But it's just there, stationary, doesn't move. So M here is 1,200, right? And it has a resistance force but it only mentions the work done by the resistance force, not like the force itself. So I'm just gonna write it here. WR, yeah. Okay, and then we have a driving force, which is 4,500 Newton. Yeah, okay. Now, we have to know, what we want to know is d meters, which is from O to point P. How many do we know the speed of D? We know. So B is 25. So here, distance will be D. Okay. Pardon my very bad drawing, but like, yeah, you get it right. Okay. If you see a question like this, the first thing that must appear in your brain is the energy method, whatever happens, okay? Okay, so what is the energy method, guys? You have to know it. Energy method is, sorry, my Apple Pencil just doesn't work sometimes. WDF minus WDR equals to delta PE plus delta KE. Yep, okay. So where do we get this formula from? Basically, the loss of PE is equal to a gain in kinetic energy, and vice versa. It works the other way around. The loss in kinetic energy is a gain in potential energy. It's conservation of energy, guys. So we already know the origin of this formula, so let's just plug in the numbers, guys. Okay, so what we know here, WDF, we know the driving force, 4,500 times. We don't know the distance because, yeah. And then we already know this, so let's just plug it in. And delta P, of course, it's 0 here because it doesn't move at a vertical height. So let's just ignore it. I'm just going to cross it out. And, okay, I'm just going to plug in KE formula. Half times 1,200 times the V final here is 25, and it starts at 0, right? Okay, I forgot to write it, but U is equal to 0 here. It's at rest. So 25 square, right, is the V final. And minus the V initial. Yeah. Okay, oops. Okay, 4,500D. It's gonna zoom it out because I really have a hard time seeing it. Okay. Plug in your calculators again. 375. Oh. Yeah, yeah. So I just need to do basic algebra. And we're gonna find a D. D is 100 meters. Yay, we got correctly. Now, question B. Okay, there's another explanation, another brand new explanation. I'm gonna read it. Car B starts off at the same instant as car A. The two cars arrive at P simultaneously and with the same speed. The engine of B produces a driving force of 3,200 newtons, and the car experiences a constant resistance to motion of 1,200 newtons. Find the mass of B. Okay, because it's pretty much the same question. I'm just gonna like copy paste, yeah, my drawing, so I don't really take a long time, yeah. Okay, I'm just gonna paste it here. Okay, now the car B starts off at the same instant as car A. So basically they start moving at the same time. And it's said that the engine of B produces a driving force of 3,200 Newton. So I'm just gonna write here. And then it said that the car experienced a constant resistance to motion of 1,200 Newtons. Yeah, so I'm just gonna write here, FR equals to 1,200. Yay. Okay, now it said that the two cars arrive at P simultaneously and with the same speed. So they arrive at the same time and they arrive at the same speed, okay? So it asked for the mass of B. So now, how do you get the mass of B? I mean, if you can see here, it's not, I mean, the resultant force, of course, it's not 0, right? Because there is constant resistance here. So delta F, I mean, sigma F is not 0. So what comes into your mind when I say sigma F is not 0? Of course, the acceleration is not 0, so we can know the acceleration. So I'm just gonna say AB, yeah. AB equals to B. Yeah. Okay, so delta F is, which is for B, is 3,200 minus 1,200 divided by MB, which is the thing we don't know. We just need to find out what is MB. What is MB, guys? Oh my god. Okay. So what we need to do next is finding out what is exactly M. So is there another formula which uses A? Of course, the SUVAT formula, guys. What can we use this time? We know the V, it's 25. We know the U, of course we know the U, it starts at rest, right? Oh, never mind. Yeah, it does. And the acceleration we know here, which is, although there's an unknown, but we still know the acceleration, right? So of course, we can come to one conclusion. V squared equals to U squared plus 2AS. So the V here is 25 again. Oh my god, the question is not creative. Yeah. Okay, so the u is, we can ignore it because it's 0, of course. And 2 times 3,200 minus 1,200 is, forgot to like calculate it, guys. What do you do? Okay, so we just need to plug in that for MB times the distance is 100, of course, because they travel the same distance to P. The P doesn't change, it doesn't move. That's just a point. Okay. Now we have 625, and we got here 400,000 MB. Now we can get the MB, guys. 640 kilogram. Yay! Now we get the M. Okay, the question doesn't end. Find the steady speed which B can maintain when its engine is working at the same rate as it is at P. So what do we know here? Steady speed. So the sigma F here is 0. This time it's 0, yeah? Working at the same rate. Okay, same rate. What comes into your mind when I say same rate? Okay, power, yeah. Power. What is power? What is the formula for power, guys? You need to know. Do an A, please. P equals to E over T. Yes, energy over time. So here. But we don't really need this formula here because we don't know the E, we don't know the T. Well, we might know the E, but we don't know the T. And I don't bother to know too. Okay, so what we can use is F times V. Right? Yeah. So I'll need to find the power first, right? Because it said working at the same rate. I just need to find out what's the rate, right? Okay. So the driving force is 3,200. 1,200 times 25, right? Because at P is 25, and it's at working at the same rate as P as it is at P. So I'm just gonna write 25. So what's 3,200 times 25? It's 80,000, right? Okay. Now we just need to know the resultant force is 0, right? So I'm just gonna write here. So we know the FD, which is driving force. We know the resistance force too, from the information above. So what I need to do is equate it to 0, and we can find out what is the steady speed, because as the power is still the same, we can find out what is the speed. So 80,000 divided by V, which is the one that we're trying to find out, and minus the driving force, which is 1,200. Equated, and we get 66.7 meter per second. Of course, I'm putting it to 3 SF. Yay, we got it, guys. Number 5 is done. Okay, I'm just gonna end.
Moving on to question number 6. A particle starts from a point O and moves in a straight line. The velocity, v meter per second of the particle at time ts after leaving O is given by v equals to k 3t squared minus 2t cubed, where k is a constant. A. Verify that the particle returns to O when t equals to 2. So first of all, when they say returns to O, it means that the displacement is 0 because it returns back to its original position. And then to find displacement, we can find the integral of the equation for velocity, this one. So integral of k 3t squared minus 2t cubed. Since k is a constant, we can pull it out, so it will result in k multiplied by t cubed minus half t to the power of 4 plus c. However, since it starts from a point O, that means the c is equal to 0. So the equation for displacement is k t cubed minus half t to the power of 4. So next, we have to verify that the particle returns to O when t equals to 2. So we can just substitute t equals to 2 in this equation. So the s is equal to k 2 to the power of 3 minus half 2 to the power of 4. So this will result in k multiplied by 8 minus 8, and this will result in 0. So the displacement is 0. So we have proven that when t equals to 2, the particle returns back to its original position. Part B. It is given that the acceleration of the particle is negative 13.5 meter per second squared for the positive value of t at which v equals to 0. Find k, and hence find the total distance traveled in the first 2 seconds of motion. So first, let's write down what we have found from the previous question. So in the question, it's stated that v equals to k 3t squared minus 2t cubed. And we have found that the displacement is k t cubed minus half t to the power of 4. Next, it's stated that the acceleration is negative 13.5. So to find acceleration, we can differentiate the equation for velocity. So we can find dv over dt, which is k 6t minus 6t squared. So that's the equation for acceleration. And then we have to find the positive value of t at which v equals to 0. So we can equate this equation to 0. K is equals to 3t squared minus 2t cubed equals to 0. So we can find that 3t squared minus 2t cubed is 0. And then we can factorize this. So t squared 3 minus 2t equals to 0. And so from here, we can find that t equals to 0, or 3 equals to 2t, so t is 1.5. We'll reject t equals to 0 because it's stated that it's the positive value of t. So our t would be 1.5. Next, we just have to substitute it into this equation along with the fact that acceleration is negative 13.5. So negative 13.5 is equal to k 6 multiplied by 1.5 minus 6 multiplied by 1.5 squared. So negative 13.5 is negative 4.5k. So we can find that k is 3. And then after we find k, we can find the total distance traveled in the first 2 seconds of motion. So first of all, we have to take note that when v equals to 0, it's the maximum displacement. So the motion would be, let's say this is this maximum displacement at here, and this is the origin. At 1.5 seconds, it would be at its maximum displacement, and then for the remaining 0.5 seconds, it would move in the opposite direction. And since we have found that in the first question, for 2 seconds, it will return to origin, so the total distance traveled is the distance traveled in the first 1.5 seconds multiplied by 2. So we can put in the limits here for k, which we already found is 3, t cubed minus half t to the power of 4. So we can find it from 1.5 to 0 and then multiply by 2. We multiply by 2 because we already know that in the remaining 0.5 seconds, the particle will return back to origin, so it would go back the entire way. So its distance traveled is the same as in the first 1.5 seconds. So this would be 2.53 multiplied by 2. So the total distance traveled is 5.06 meters.
Respectively, are moving down the same line of greatest slope of a smooth plane. The plane is inclined at 30 degrees to the horizontal, and A is higher up at the plane than B. When the particles collide, the speeds of B are 3 meters per second and 2 meters per second, respectively. In the collision between the particles, the speed of A is reduced to 2.5. Find the speed of B immediately after the collision. Okay, what I'm going to do now is draw. So we know it's 30 degrees here, and the fact that A is higher than B. But we know that they're moving at the same direction because the question said they're moving at the same line of the greatest slope. So I can assume it's going down. It's going down. So this one is 0.4, and this one is 0.2. As what we can see, there's a collision, right? So we will assume that there is momentum here going on. So what's the formula for the conservation of momentum? P before equals to P after. Nakan? Nah. So I can assume that MA UA plus MA, I'm gonna move it here because it's too space. I need space. Is equals to MA PA plus MB PB. So I just need to plug in the numbers and we're fine because we know that they're moving at the same direction, so we don't have negative speed or negative velocity here. So I'll just need to plug in the velocities as it is. So 0.4 times 3, right? And then 0.2 times 2 equals to 0.4 times 2.5, right? Because they decrease. VB, because that's the one that we're going to try to find. So now we get the VB, which is 3 meters per second. Okay. So now, what do we want to find out in the other question, which is speed? Okay, I'm gonna read it. After the collision, when B has moved 1.6 meters down the slope from the point of collision, it hits a barrier and returns back up the same line of greatest slope. B hits the barrier 0.4 seconds after the collision, and when it hits the barrier, its speed is reduced by 90%. The two particles collide again 0.44 seconds after their previous collision, and they then coalesce on impact. Show that the speed of B immediately after it hits the barrier is 0.5, and hence find the speed of the combined particle immediately after the second collision between A and B. Okay, since this is quite a hard part, please focus. Okay, so I'm just gonna make a new diagram because there's new details here. What stays is of course is the degree of the inclined plane. 30 degrees. And now I'm gonna put more focus on object B because that's the one we're emphasizing now. Okay, so I'll just assume A is somewhere, but let's just neglect it first and let's just focus on B. Okay, so here I'll just put P here, and what we know is it has an angle here. So before I'm going to find the WX first before I jump into other details. So the WX here, how do we find WX? We need to find a weight, right? Okay, so the weight is the B is 0.2, right? WX will be then 2 sine 30. So what do we know next? It hits a barrier. So this will be the barrier, yeah, sorry. And when it hits the barrier, it moves up again. So it moves after it hits the barrier. It's like rebound, something like that, okay? But then after it hits the barrier, it decelerates. So when it's like fast hitting the barrier, it then decelerates somehow. Okay, so we know, right, that it decelerates. So what we know is sigma f is not zero after it hits the barrier. So for particle B, I'm gonna find sigma f because as we know, that's the only thing we know now, right? Okay, so what we know next is there's no other force, any horizontal force acting on the object other than Wx. So I can assume sigma f is only Wx. So I'm just gonna put 2 sine 30 and equals to the s. But what do we know here is the sigma f, it's the Wx here is negative because it decelerates, right? So we need a negative acceleration. So I'm gonna like assume this will be negative. So negative 2 sine 30 divided by 0.2 is negative 5. Am I right? Oh, never mind. We don't consider negative here. I'm sorry, I'm wrong. Okay, sorry. Pardon me for that. Now we get 5 meter per second squared. Now, what do we need to do next, and what do we need to know? Okay. Now we have to use the Suvat formula because we want, and we need to find out what exactly is VB after it hits the barrier, right? That's what we try to find out. Okay, so I'm gonna try to find out, yeah, VB squared. We use the V squared to equals to U squared plus 2AS because that's the only formula which incorporates all the things that we have now. Like U, which is from this question, right? We know what is the initial speed of B. We know the S, traveling at 1.6 meters down. And yeah, we also know the acceleration, so that's a perfect match. Okay, so 2AS. So we need to find out and plug in all the one we have. So I'm gonna plug in 3 here. 3 squared plus 2 times 5. 1.6 is equals to root of 25, which is 5 meters per second. Now we know that VB is 5 meters per second. So we have answered one of the questions in this number. There's like 2 questions inside. So what do we need to know next? The speed of the combined particles. Okay, this one will get a little bit tricky. So what step do we need to do next? What we know, after it hits the barrier, the speed of B is reduced by 90%. Reduced by. So what is speed now after it's reduced? VB after hit barrier will be 10%, right, of its initial speed. I mean, I'm just gonna say its initial speed because it changes after that, right? So we have 0.5. So yeah, okay, we get it 0.5. Now, what do we do next? The only time we have here is 0.44 seconds after the previous collision. So it's like the total time from their first collision until the coalesce. Like, yeah. And we know that it hits the barrier 0.4 seconds after the collision. We need to find the difference in time, the gap between 0.44 and 0.4, to know the time right before the second collision starts, right? So what I'm going to find out now is the time. T right before. Okay, now we know the time right before the collision. But in order to use the formula of MAUA plus, yeah, that formula, we also need to find out what is VA after 0.4 seconds, because of course it will change, right? This is basically after the first collision because the speed of A is here, 2.5. It is the speed in the collision, but we need to know what is the speed after like 0.4 seconds after the collision. So it's our task to find this out now. How do we find out VA after the first collision? It's really simple because we just need to use the Suvat formula again. So I'm gonna find out VA. So what is the initial speed of A? The last speed that we know is 2.5. Right? Yeah, that will be its U. And the next thing we know is the acceleration of VA which will be 5. And we also know that it spends 44 seconds after the first collision, 0.44 seconds. So yeah. So the collision, after the collision, the VA is 4.7. So now we have gotten it, we have at least got one of the objects after the first collision. But we don't know what speed of B after the collision, right? So we now have to know what is the speed of B before the second collision, right? Because it undergoes a hitting of the barrier, which is not what VA gone through, right? So I just need to know for B, there's a difference what we want to know. For VA, we want to know the speed of A after the first collision because that's the last event it experienced. But for B, what's the last thing it experienced? Hitting the barrier. And right before the second collision, we want to know its speed of B because that's the last thing. The hitting the barrier was the last thing. But what we're trying to find out now is not 0.5 again or anymore. What we're trying to find out is the speed right before the second collision. There may be an increase or decrease after 0.5. We don't know. So, BB right before second collision. Which is VB, UB plus AT. What is UB, guys? 0.5, because that's the last thing it experienced, right? And of course, it decelerates after it hits the barrier. So yes, this is the motion. It hits the barrier, but you see my hands, it's fast and it's slow, like it's decelerating. So acceleration is negative after it hits the barrier, right? So I just need to find out, what I'm trying to find out is VB right before the second collision. So the acceleration will be -5 now, times the t, which will be 0.04, because that's the gap that we're trying to find the time for. So we get 0.3 meters per second. Now we can easily use the MAUA formula. MAUA plus MAE. Oh my god. MA and MB is now one single particle, so I'm just gonna edit. Okay. So the MA we have here is 0.4, and the one that we've counted for, and then 0.2. Negative 0.3 because it's experienced deceleration, and MA and MB, which is 0.6 now. Okay, now we get the answer, which is around 3.03 meters per second, which can be put into 3SF. Okay, that will be the end of question 7. Thank you for listening. Bye.